In this video, we are going to explain in detail the meaning of the F7 error code in air conditioning units from different brands and models. This code appears very frequently on the display of residential and commercial units, creating confusion among users and beginner technicians who often do not know where to start diagnosing it because its interpretation varies from one manufacturer to another. For that reason, it is essential to fully understand its different interpretations and the causes that can trigger it, as this allows for a much more accurate diagnosis, saves time, prevents unnecessary part replacement, and provides a better understanding of the system's internal operation. Although there is no official standard for this code, F7 is usually associated with faults related to temperature sensors, electronic protection functions, overload conditions, or communication problems between the system's electronic boards. Deeply understanding the context in which this error appears allows you to determine whether it is a temporary failure caused by electrical variations, an automatic protection alert preventing major damage, or an actual component failure that requires technical intervention. Below are the most common groups of meanings organized by similarity to facilitate diagnosis. This classification allows you to analyze the origin of the problem in an orderly way, starting with the most frequent failures, which are usually the easiest to solve, and moving toward the less common but equally capable of triggering the F7 code, which require more detailed analysis. Temperature sensor failure, most common interpretation. In a large number of units, the F7 code is directly related to a defective, disconnected, or out-of-range temperature sensor. Depending on the brand, it refers to different sensors: suction, evaporator, ambient, coil, among others, since each manufacturer uses its own internal criteria to assign codes. In all cases, the principle is the same. A sensor sends an incoherent or impossible reading, and the control board interprets that there is a risk in the system. Brands that use F7 for sensor failures: Higher, suction temperature sensor failure; York, in some manuals, related to evaporator temperature sensor; Galance, indoor temperature sensor failure; Kenwood, mini-split, defective ambient temperature sensor. Typical causes: open, shorted, or out-of-range thermistor producing incorrect electrical values; loose, corroded, or damaged connectors interrupting sensor readings; sensor disconnected due to vibration, previous servicing, or poor installation; sensor burned due to overheating caused by thermal failures in pipes or coils. What it means: the electronic control board stops receiving reliable temperature signals. To prevent damage to the compressor or refrigeration circuit, a protection mode is activated that prevents the unit from operating normally, since running without accurate readings is risky for the entire system. Recommended diagnosis: A. Turn off and unplug the unit. Wait a few minutes and turn it back on to rule out a temporary failure or an error caused by momentary electrical fluctuations. B. Inspect the physical condition of sensors, connectors, and wires, ensuring there are no broken wires or loose fixations. C. Check for moisture, corrosion, or cracks in the connectors, as these can alter electrical resistance. D. Measure the sensor's resistance with a multimeter on the kilo-ohm scale to verify if it responds as expected. E. If the reading is infinite, open sensor must be replaced because continuity is lost. F. If the reading is 0, shorted sensor must also be replaced, as it will no longer detect temperature changes. G. Compare measured resistance with the manufacturer's table. If it does not match the ambient temperature, the sensor is uncalibrated or damaged. H. If everything in the indoor unit seems correct, repeat the tests on the outdoor sensors, where failures are also common. Conclusion for Group 1. Thermal sensors are essential for the electronic boards to control the operation of the unit. If any sensor stops sending a valid reading, the system interprets a risk condition and will display the F7 code as protection, preventing major damage to the compressor or other sensitive components. IPM module overheating, or electronic protection. In many inverter units, especially from well-known brands, the F7 code is related to protection of the IPM module or the circuit that controls the compressor. This type of fault is more critical because it implies overload, excessive temperature, or malfunction in power components which operate with high currents and require proper thermal conditions to prevent permanent damage. Brands where F7 is related to the IPM module. Train, high temperature protection of the IPM module. Orus, excessive temperature in the IPM module above its normal operating range. Typical causes: high ambient temperature in the outdoor unit, making heat dissipation difficult. Dirty condenser increasing compressor load due to poor thermal transfer. Outdoor fans stopped or spinning too slowly, preventing proper ventilation of the module. Excess refrigerant or line restriction causing extra load on the compressor. Internal IPM module failure due to wear, overcurrent, or deteriorated components. Poor heat dissipation due to dirt, obstructions, or poor unit placement. Communication failure between the main board and the inverter compressor causing the module to operate out of sync. What it means: the system locks itself to prevent damage to the compressor or electronic power circuits, as these components are expensive and sensitive to overheating. Diagnostic recommendations. A. Check airflow and clean condenser and evaporator coils to ensure adequate heat dissipation. B. Verify refrigerant level and ensure there are no restrictions causing abnormal pressure. C. Measure system pressure and compressor current to confirm it is operating within parameters. D. Perform a system reset after correcting the causes and verify whether the error disappears, indicating that the protection worked as intended. Conclusion for Group 2. In this case, the F7 code does not necessarily represent a direct fault, but rather an automatic protection signal. The objective is to prevent severe damage when the system operates outside safe parameters, protecting the compressor and internal electronic components. Communication failures or specific system functions. In certain models, especially VRF, multi-split, or units with auto-lifting panels, the F7 code may be linked to communication problems or failures in specific modules of the unit that require continuous electronic coordination to operate correctly. Brands with this interpretation. Daikin, in some VRF multi-split systems associated with communication failure in the auto-lifting panel. Mirage, communication problems in the decorative panel or abnormal voltage affecting signals between boards. Carrier, communication error between the control board and the indoor unit, according to code databases. Typical causes: loose or improperly connected communication cable interrupting data transmission. Indoor-outdoor boards not synchronized due to internal faults or electrical fluctuations. Out-of-range voltage affecting data transmission and operation of electronic modules.